Hey guys, let's talk a bit about Python slicing. Okay, the slicing is an important part of the list. The list is a data structure of Python, and slicing is an important part because it lets us extract the elements of the list. For example, other language you might have to iterate through a for each loop or a for loop, for instance, and then grab the elements of the list. Instead, in Python, naturally, using just the numbers and colons, we can get the list. For small lists, it might, for examples or instances we take in practice, it might not be so effective. But in case we have bigger lists, we have files, and because Python is useful in machine learning or data science or data analysis and other analysis things, it's very essential to learn slicing. And now let's start doing slicing. And here, let's not try to look at some screenshots or slides like we have previously done. Instead, let us try it on our own. Okay, how slicing is actually going to work, because we know the models of the slicing. Let's elucidate on how we are going to do this list. Okay, first let us consider a list. It's probably of 10 numbers, I guess. Yeah, it's 10 numbers. Let's take a list of 10 numbers. The bigger the list, the more clarity is what we get. Okay, and now let's start with the basic listing, the basic slicing. Okay, okay, why do I get actually only 77? Here, the thing is, we have specified list of 1 is to 2 is to 7. 1 colon, 2 colon 7. Okay, we are starting from the first index, that is 77, which is pointing to 77, and then we are going only to the second index, but we are skipping 7. So we are not. So here the thing is, how it actually. Okay, let's look at a better instance. A better one. Let's use smaller numbers. Okay, I get 77 and 75 right now. Why do I get 77 and 75? It's because, okay, I'm going to start with 1, which is the first index. The first index points to 77, obviously. And then 75. Okay, why did we get 75 over here? Let's make an analysis. It's important to make an analysis of the output. Okay, 78, 34, and then we have 75. Why? It's because we are skipping 3 out here. We don't actually skip 3 because we are including 77, but we are getting 75. There, the number of elements in middle are 2, and that is we are just making 2 hops. I mean, so here we find out that we are making hops over here. So 3 minus 1 is 2. So skip 2 elements in between. So 77 to 75. Okay. And another thing, what is the function of this 5? Let's get a clear view of this. Why 5? I'm going to go to 9. I get 77, 75 and 98. And 98 comes at the 8th index. Or maybe it's the 7th index, sorry. Why? Okay, we start from 77 and then we go to 75. Okay, we are skipping 2 elements like we have previously formulated. 3 minus 1 is 2. We are skipping 2 elements and going to 75. And then 98, that is we are skipping from 75 to 98. Again 3 minus 1 2, we are skipping 2 elements, that is 97 and 23, and then we're going to 98. And now 9 in the middle specifies the last index. Okay, the 9th index. So 9th index will be the last one for this slicing to traverse to. Okay, the slicing internally is going to perform an iteration and going to give you elements. So here this is what we are doing. For example, I'm going to skip only 2 elements. So 2 minus 1 is 1. I'm going to go to the 9th one again. See what I'm going to get. 77, 34, 97 and 98. Okay, where are we? How did we go there? We start from 77 and then skip to 34, that is 2 minus 1, and then 34 to 97, 97 to 98, and 98 to 34. We're not going to 34. Why? It's because we are only specifying 9. So maybe let's count. Okay, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe Thing is, it's supposedly going only within the range of the last element, that is before what's before the last element. For example, if I'm going to hit it with 10 instead of 9, now you get 34. So with this we understand that it's not, the element which you specify in between, I mean the index which you specify in between, it's not going to go there. It's only like a length. It is like a position. It's like a natural position, like the position from the natural numbers. So 10 minus 1, the middle number minus 1 is going to give you the index. Okay, that is what it seems to be. Okay, this is one kind of model. Now let's look at another model. Let's not specify anything. Okay, I'm gonna go, since the middle one also specifying the last element, I want to skip 2. Let's see what's output on it. Okay, 9, 78, 75 and 23. Why? So okay, first let's talk about the empty column we haven't specified yet. So 0, I mean null, we haven't specified anything, implies that it's gonna take the default index, that is 0. Okay, 0 is a default index, so it's gonna start from 9 and then skip 9 to 78, 78 to 75, 75 to 23. Okay, since we have specified 8, so 8 minus 1, 8 is the natural position, but index wise 8 minus 1 is 7, so it's gonna go only up to the 7th index. So it's gonna traverse only to the 7th index and return you all the values. Okay, now instead of nullifying the first element, let's nullify the second one. Let's start at 3 or specify the middle value. Okay, so we have 34. We're starting at the third index as we specified, and then skipping 1, getting to the 97, 98 and to 34. Okay, if you're not going to specify anything in between, it implies, I mean it implies to itself that you have to go up to the end of the list. So not specifying the first value indicates that it has to start from the first. Not specifying the last one indicates that it shouldn't, it should consider the last element, up to the last element. There is a default indices we actually talk about in the list. Okay, now let's remove 3. So we're not specifying the first one, we're not specifying the last index. I mean, we're not specifying both the origin index and also the final index it has to traverse. So it's gonna print all the elements with one skip. So it's gonna start at 9, 78, 75, 23, 22. It's gonna skip 34. Since 34 is the last one, it's never gonna print it again. In case we're gonna do 1, it's gonna print all the elements, of course, because 1 minus 1 is 0, so it's not gonna skip over anything else. And so it's going to start from the first index because we haven't specified anything. It's going to end at the last index because we have not specified anything again. So, and you're not skipping anyway, just giving one hop. So the last one you can always consider it as a hop so that you won't get confused. Now let's give this hop as minus 1. So see, it prints the reverse. So minus 1 at the end indicates that you print all the numbers, I mean all the contents of the list in the reverse order. So minus 1 here actually, okay, let me elucidate this. Minus 1 here actually indicates the first element from the last. So you can actually follow the natural way. There is 1, 2, 3, 4, 5, 6, 7. So the last index of an array of a list of 10 would be minus 10. I mean the first index would be minus 10 if you come from the last. So if I say LT of minus 5, it's going to print the fifth index, which is a 97, minus 1, minus 2, minus 3, minus 4, minus 5, count from the last. And if I do minus 10, okay, note that the length is 10, so it's going to print out the first one. If I'm going to give minus 11, it's not going to do it because it says the list index out of range, because you're actually going out of range. Minus 11 indicates the element next to 9 which is not present. so it doesn't point out to anything, so it returns an error. It's kind of an exception, you can say. It's out of range. So now we haven't looked at another basic one, that is 1 to 6. Of course, it's very easy for us to judge what happens is. So it starts from 77 and ends at 97 because we have specified up from 1 to 6. 77, 78, 34, 75 and 97. So 0, so 1, 2, 3, 4, 5. So it indicates that the second the one after the colon in a two number specification, the second one is considered as a length. 6 minus 1th position. Okay, that is how it works. 6 minus 1th position, so you get from the first index to the 5th index. Okay, we can actually make another try so that we get clarity about this. So I'm going to start at the second index. I'm going to go to the 8th one. So 8 minus 1 is 7. So you get to the 7th index. So you start from the first one, which is 78, 34, 75, 97, 23 and 98. Let's count the indices. It's 1, 2, sorry, it's 2, 3, 4, 5, 6 and 7. So this is how the splicing is actually working. And yeah, and we have missed one more, I guess. Okay, we have the negative values, LT. I'm going to specify this one. We'll see how it's going to end up. -1. We haven't get anything. Okay, let's specify something else. We still haven't got anything. Okay, now I'm sorry for that. Now we have something. Okay, let's check how this is working. Starting from the reverse, 98. So yeah, -1 at the end only indicates that you have to start from the last. Okay, where the list ends, that is a position where you have to start from. That is what the -1 at the end is actually indicating, not exactly the position always. Okay, so -1 indicates that. So Python understands that -1 at this position indicates that it has to start from the last. So the iteration begins from the end of the list rather than from the front of the list. So it says -1 and then we get to have the 7th position. Okay, this is 7, 8, 9. So 9, 8, 7. The 7th position is 98. So we start from 98. So the first 98 and then we go up to 78. Here 78 is the second index. Second index, in the sense here 1. So 1 here we are going to add +1. So always remember that whatever you are going to specify in the second column, okay, it indicates that go to the element before that. So iterate until you approach this. Okay, so it indicates that 7, 1, -1. -1 indicates that you start from the end, and 7 indicates the 7 in the front. The first column indicates that you start from the 7th index from the reverse order and end at an index which is 1 greater than the in the second column. That is how the reverse iteration works. And let's skip out something. So this says that you start from the first and end at the second index. It goes up right away to the 78. I guess you got that. So an empty one indicates start from the default index. So since you're starting from the last, the default index is gonna be 34. However, and finally, before we end it, we again say to start it from 7, but I don't want this. So it's gonna say go up to the default value of the index. Go to the default value. So it's going to go up to 9. So, but I'm going to explicitly specify the 7. So the 7th index, that is 98, and then go up to the last one. So this is splicing, and splicing is very important. It's not trivial at all, because for the most of the things we might be doing, it's not just about the I mean, it's not going to talk just about the just these numbers. For example, I'm going to give you one final example. It could be this. I have this list. Sorry, I'm forgetting about the commas. Okay, we have these things. Let's go use LT1. Okay, now I'm going to do the same thing for this one. I want to start from the last, but I want to end up at the first index. I want to start it from the 6th. How many do I have? 0, it's 6. So I want to start it from the third one. I want to end it up the default value, that is the 0th index. I want to start from the last. I'm sorry. See, it does not. A list is not just about numbers. It's also about a lot of things. A list can contain numbers as well as any other data type you want. Okay, it's a combination of all the data types you have, just like a structure, and see how you see. So this is something how you actually deal with things you don't understand. You don't really have to read the documentations and all. Give a practical approach to these kind of, and Python is an interactive language. Now that it's an interpreter, you can actually have a command-like interface, a command-like dealing with Python. That is one to one. Thank you.